Pluto, a far-off and confounding, more unassuming planet, was once a solitary individual from our close-by planet gatherings, our planetary family. At any rate, later upsetting declarations by leading astrophysicists Neil deGrasse Tyson and Michio Kaku brought Pluto back into the spotlight with a stunning exposure. They suggest that this crisp world is on a potential compacted illustration with Neptune. Yet, how is it that this could end up actually working? Moreover, what might be the aftereffects of such a huge event? Are we seeing an intriguing, grandiose characteristic, or is there something else to this coming perpetual mishap? Go alongside us as we explore the anticipated consequences of a Pluto-Neptune influence. Pluto, a previous planet that was limited to a planet midway in light of its unpredictable circle, remains a subject of interest and study in the vast community. According to recent assumptions by leading researchers, Pluto's course is dangerously close to Neptune's. Leading astrophysicists Neil deGrasse Tyson and Michio Kaku are both raising the alarm of a possibly risky mishap between these two planets that could be a colossal danger to Earth. Yet, how is such an event even conceivable? Pluto's orbit around the Sun is unlike any other planet in our close-by planetary system. It requires a stunning 248 years to complete a singular orbit. This suggests that since its discovery in 1930, it hasn't even completed one full revolution. However, the interest doesn't stop there. Pluto's way is marked by its extraordinarily curved shape, wandering totally from the nearly round orbits of the major planets. What makes Pluto's orbit even more astounding is its inclination, not entirely set in stone at 17 degrees to the ecliptic plane. The manner in which Pluto follows is significantly more extreme compared to other planets. This propensity and whimsicalness add layers of complexity to its orbital pattern. One of the most fascinating parts of Pluto's orbit is its gathering with Neptune for around 20 years in each orbit. Pluto, in reality, draws closer to the Sun than Neptune, contradicting what we could expect from their positions in the planetary system. This prompts the customary question: why hasn't Pluto collided with Neptune? The answer lies in the gravitational effects of various planets. The examination of Pluto's orbit began not long after its discovery. Initially, space specialists attempted to make heads or tails of its remarkable path. Unlike other planets whose orbits lie relatively close to the ecliptic plane, Pluto's orbit stood out with its steep inclination and unconventional shape. The mystery deepened with the acknowledgement that Pluto's orbit actually does, indeed, cross Neptune's. The stability of Pluto's orbit amid these complexities is proof of the intricacies of celestial mechanics. The three-body problem in space is about figuring out how three objects in space, like Pluto, Neptune, and the Sun, move and influence each other with their gravity. It's like trying to predict where they will go based on where they start and how they pull on one another. In Pluto's case, this problem shows how its orbit, Neptune's orbit, and the Sun's gravity all work together in a complicated way. Terms like asymptotic libration, expansion libration, and the VSK oscillation are part of this conundrum. According to astrophysicists, what's keeping all planets in their orbits is a sort of libration concerning Pluto and Neptune. This term refers to the fact that whenever Pluto crosses Neptune's orbit, its position is always at least 90 degrees away from Neptune. This spatial division is key in keeping their orbits from interacting. Degree libration, on the other hand, refers to the vertical movement of a celestial body in its orbit. For Pluto, this means that when it comes closest to Neptune or any other giant planet, it is situated far above their orbital plane, providing an extra layer of protection from potential collisions. Another critical factor in this situation is the VSK oscillation, named after three scientists, VAV, Apple, and LV. This concept studies how things move in space. It's about how three space objects, like Pluto, Neptune, and the Sun, pull on each other with their gravity. This pull influences how they move, and in Pluto's case, the VSK helps us understand why its orbit around the Sun is so unique despite the apparent chaos. This oscillation helps keep Pluto's orbit stable for an extraordinarily long time. The VSK oscillation shows that, although things in space might seem wild and erratic, certain patterns and rules keep everything in place. These factors help keep Pluto's orbit stable, ensuring it doesn't crash into Neptune or stray off course. This three-body problem helps us understand how these orbits change because of how space objects pull on each other. Studying this helps us learn more about Pluto, our planetary system, and distant stars and planets. Mathematical simulations in the late 1980s revealed that, despite these consistent properties, Pluto's orbit is, in fact, chaotic, with minor deviations in initial conditions leading to significant differences over an extended period of time. However, these amazing properties of Pluto's orbit have been found to maintain stability over remarkably long periods. In fact, observing the chaos through computer tests has helped us understand how the giant planets like Neptune, Jupiter, and Saturn influence Pluto's orbit around the Sun. Neptune has a special relationship with Pluto, where, for every 2 orbits Pluto makes around the Sun, Neptune makes 3. This resonance helps keep Pluto's orbit stable. However, Neptune isn't the only one helping. Jupiter's gravity also has a massive impact on stabilizing Pluto's orbit. Saturn helps too. These tests show that Jupiter's gravity alone is strong enough to ensure Pluto stays on a stable path for an incredibly long time, possibly even billions of years. Perhaps Neptune, Jupiter, and Saturn are working together to guarantee Pluto can continue moving safely in space without running into trouble. These attributes are important in the larger context of the universe, helping maintain the control and consistency of celestial body movement. Without these factors, the nearby planetary system, as we know it, would be a place of much greater chaos and unpredictability. Bodies like Pluto might actually collide with others or be shot out from their stable orbits, leading to a cascading effect on other celestial bodies. For Pluto, particularly with discussions about it possibly colliding with Neptune in the future, understanding its orbit is crucial. This gives us a clearer picture of the nearby planetary system's dynamic nature. The case of Pluto exemplifies how even the most seemingly unstable orbits can achieve a state of equilibrium. The complicated association of gravity, rotational powers, and orbital mechanics additionally shows the significance of consistent perception and examination of these peculiarities to all the more likely handle our situation in the universe. Investigating the profundities of space frequently drives us to stand up to the whimsical idea of divine bodies. Furthermore, Pluto's circle is an optimal illustration of this eccentricism. The idea of orbital turmoil, which alludes to the delicate reliance of a divine body's orbit on its underlying circumstances, is obviously exhibited on account of Pluto. This implies that even slight varieties in the Bantam planet's situation or speed can considerably change its long-term orbit. Utilizing computer simulations has been unquestionably helpful for examination to sort out how Pluto moves in space. These reproductions utilize complicated math to mimic how Pluto, alongside other space objects like Neptune, pull on each other. By changing little subtleties in the reenactments, space experts can see how, indeed, even little changes can make a gigantic contrast in where Pluto winds up. In the late 1980s, these recreations showed something truly intriguing about Pluto's circle. Notwithstanding having components like asymptotic and scope libration to keep it stable, its circle can in any case be wild and whimsical. On the off chance that you start with even a little contrast in where Pluto is or how quick it's moving, over numerous years, its way can wind up looking altogether different. In any case, notwithstanding this bedlam, Pluto's circle stays stable for significant stretches, billions of years. This implies Pluto's excursion around the Sun has a kind of request to it, even though it appears to be crazy right away. Foreseeing colossal occasions, particularly when they include tempestuous circles like Pluto's, presents colossal challenges. The innate unusualness of these frameworks implies that drawn-out forecasts are frequently loaded up with vulnerabilities. While mathematical reproductions give a strong device for understanding and foreseeing the future behavior of divine bodies, they likewise highlight the restrictions of our prescient capacities. These models vigorously depend on the exactness of beginning circumstances and the intricacy of the associations they reproduce. Any slight mistake or twisting can prompt drastically various outcomes, making accurate predictions a staggering task. In addition, the turbulent idea of heavenly circles like Pluto's reminds us of the consistently developing and dynamic nature of the universe. While we have made gigantic steps in figuring out space, the instance of Pluto advises us that our insight into the universe still stays restricted. Understanding the gravitational impacts of the Goliath planets on Pluto's circle gives significant bits of knowledge into the more extensive elements of the planetary group. It shows how the presence and position of each planet can make clearing impacts, impacting the soundness and bearing of different bodies within the framework. So, why are some astrophysicists recently raising concerns about a potential impact between Pluto and Neptune? Notwithstanding this multitude of perplexing powers working to keep such an event from occurring, Neil deGrasse Tyson, a prestigious astrophysicist, offers a unique perspective on the secrets of our nearby planetary framework, particularly the captivating instance of Pluto. Tyson, known for his role in renaming Pluto from a planet to a dwarf planet, offers insightful critique on the evolving nature of heavenly mechanics and the general public's curiosity with the disregarded scopes of space. Tyson's position on Pluto's renaming is grounded in the steadily developing information on our planetary framework. He sees the renaming not as a downgrade, but rather as a vital change in accordance with our developing comprehension of the many bodies circling our Sun. Tyson's approach to divine mechanics is one of consistent learning and change. He sees the intricacies of Pluto's circle as well as its interactions with Neptune through a lens that recognizes the erraticisms of space. He suggests that while Pluto's circle is stable for the present, it could undergo huge changes later on. This possibility serves as a reminder of how much we still need to discover about the forces shaping our close-by planetary system. Taking everything into account, Pluto's circle is a captivating contextual investigation of the complex transaction of gravitational forces in the nearby planetary group. While its way is stable now, the perplexing dynamics between Pluto, Neptune, and different planets still mean that indeed, even the most apparently consistent circles could change after some time. As astrophysicists like Neil deGrasse Tyson continue to explore the mysteries of the universe, they assist us with better grasping the fragile equilibrium that governs the movements of heavenly bodies. The potential for a Pluto-Neptune crash isn't necessarily inevitable. However, it's a sign of the continually developing and capricious nature of the universe. Not enduring the logical hypotheses surrounding Pluto's circle, it's vital to consider the more extensive ramifications of these dynamics for our understanding of the planetary group and the universe at large. While Pluto's journey is one of interest, it's also a reminder that the universe is loaded with secret intricacies waiting to be explored. The concept of orbital resonance, particularly between Pluto and Neptune, is a critical piece of the riddle. This resonance, where the proportion of Pluto's and Neptune's circles is 2 to 3, is an astounding feature of divine mechanics. For each 2 orbits Pluto finishes around the Sun, Neptune completes 3. This proportion ensures that despite the circles crossing, the 2 planets never impact. This is an outcome of the gravitational interactions that stabilize their paths, working together to prevent any devastating effect.